Hi, it's Renata here. If it's your first time here, welcome to my channel, The Quant Girl, where we are going to talk about some topics in applied mathematics, in pure mathematics, in quantitative finance, and in Python program, because I'm a PhD in mathematics and a financial quantitative analyst, and I'm here to share with you some of my experience. So today we are going to work on a data science project. An interesting project in natural language process is to extract relationships from a given text. So the challenge we are going to work on this video today is exactly this type of project. We are going to extract relationships and networks from Harry Potter series books. We are going to build a social network for the characters using natural language process and network analytics. In the end of the video, we are going to have a network graph for the characters, and we are going to answer two questions. What are the most important characters, and what are the main communities in the network? We are going to use a dataset from Kaggle to take the names of the characters. You have the link for this dataset in the description of the video. We are going to use the Space Library for text process and named entity recognition, NetworkX library for analyzing the networks, and the Pybs library for network graph visualization. So now that we know what we're going to do today, let's go to Python and start coding our network. So now we are ready to code our network in Python. The first thing that you need to do is to import the libraries that we are going to use in this project. Some comments here are that we are going to use displays from space for visualizing entities, from named entity recognition. We are going to use matplotlib for some plot series, and we are going to use Pybs for more dynamic visualizations of our network in the final of the video. So let's import the libraries. Now we need to import the English language from space and load it into a variable called NER, named entity recognition. So now let's take some words about our strategy here in this project. About the strategy we are going to use here, first we tokenize a book into a list of sentences and then label each sentence by the name of the characters that appear in the sentence. Second, we define a window size of how far two sentences are apart from each other, and assume that if two characters appear in two sentences within this window, then there is a relationship between them with the named entity recognition. We are going to recognize all types of entities from text, from persons' names to organizations' name to location and so on. The good thing is that we know all the characters' names in the books from the Kaggle CSV dataset that we are going to import here. So we can easily automatically filter out all the entities that are not characters, such as names of houses like Gryffindor or classes, for example, but if you like, you can include them for extra analysis as well. You can easily find all the Harry Potter books in text files. Search these on internet. So now we are going to import all text files using OS library, and then we can search for all the files in the directory you saved them. In my case, a folder called data using scandir method. So let's check what is inside the data folder. So we can see that we have all the 7 books from the series, but today in this video, that is the first part of this project, we are going to do our analysis only in one of the 7 books of the series. But later in a second video, that will be the second part of this project, we are going to go deeper in our analysis, and we are going to expand our analysis over all the 7 books of the series. But by now, today, let's just focus in one of the books. So let's choose the second book of the series and read it. Okay, let's visualize the identifier agent with the displays. Let's first do this for the first 3,000 characters of the book. So let's run and see what happens. Okay, we can note that Space does a really good job at identifying name agents. For example, one of the main characters in the book, they are cardinal or ordinal or cardinal types of words. Now let's go ahead and load the dataset we got from Kaggle. So let's print it. We have a lot of information here, but the only column that we are interested in this data frame is the name column, which represents the characters' names. Okay, now we will create a column for the first name of the characters, because most of the time the characters will be mentioned by its first name instead of its full name. For example, Hermione Granger is just Hermione. So first name will might be useful for our analysis. For this task, we are going to use an apply function on the characters names column, and use a lambda function to split the name into different words, and then we take the first word, which is the first name of the character. So let's print out the data frame again to check that everything is okay. So now we have a column for the first name of the characters. Now the next step we are going to work on is go sentence by sentence through the text and create a list of entities. So we are going to create an empty list. We are going to create an empty list to store named entities list for each sentence. For each sentence, we will create a list that stores the entity for all entities that appear in the sentence. Then we append the sentence and its entities for the bigger list of lists. So let's print the list of sentence and its entities. Yeah, it can take some time because we are going sentence by sentence in the text. Okay, while the cell is running, we can comment the next step. So in the next step, we are going to create a function that filter out entities that are not characters. So the function will take the list of entities and the characters data frame and will return a list of entities only if the entity belongs to the character column or the first name column of the characters data frame. Doing this, we are going to keep only characters names or characters first name as entities. Okay, so here we have each sentence and its entities, the entities for the sentence. Okay, now let's run the function that filter out non-character entities and let's check if the function is working. So yeah, it's okay. So we have a sentence here, Harry, Renata and 5. Harry is a character, but Renata and 5 is not a character name or a character first name. So now let's use an apply function to apply this filter out function in the whole column. So as we mentioned before, as you can see here, some sentence has no entities. So this sentence doesn't matter for us, and we are going to remove these cases. Okay, now we have only sentence that has at least one named entity. Now we are just going to filter characters names in the entities and let's print it. Yeah, so now we have a sentence, its named entities, listed entities, and finally the final filter that is we want only entities that are characters. So now we arrived in an even more interesting task in our project. Now we are ready to build the characters relationships. Now we will specify a window size. Let's take it as a window size of 5 sentences. So each row is through 5 sentences in the text and identifies the characters appearing in the same window. So let's print it. Let's run and print it. So a comment here is that we can have some duplicated characters. So it is not interesting for us because we don't want to analyze the relationship of a character with itself. So because of this, we remove the duplicate characters that are next to each other in the window. So now let's create a data frame for the relationships we build in this cell. And let's print the relationships data frame. Okay, let's move on. And the last thing that we need to do is to aggregate duplicated and reversed relationships. For example, these ones are duplicated relationships, and Hermione Harry and Harry Hermione, Hermione Harry and Harry Hermione are reversed relationships. So we will aggregate these cases together and create a weight column indicating how strong the relationship between the two characters is. It counts how many times the relationship appears in the text. For example, in these three lines, 3 times. And we will sort the column wise and then identify the duplications. For each row, we create a value for the relationship that is basically the weight as being 1, and after we group by source and target and take the sum of the values. For example, here Harry is the source, Hermione is the target. So again, for each row we create a value for the relationship that is basically the weight as being 1, and after we group by source and target and take the sum of the values, having the final a value column indicating how many times the relationship appears in the text. So now we have a data frame of relationships. Okay, so Harry and Hermione has a very strong relationship. Dudley and Harry also, and so on. So now let's move on, and an even more fun step in our project is now this step. We will do graph visualization and some analysis on the graph. Through NetworkX library, we can generate a graph based on a data frame. This data frame we just created contains the source and the target. So this data frame. So every edge in the graph will have two nodes. The source, for example, here Harry is the source, and the source node, for example, here Harry is the source node, and the target node, for example, in this example, Vernon is the target node. So now we will use NetworkX again to visualize the graph. Okay, we have our graph here, but it's not very interesting because it's very static. We can The names are hard to see. We have a lot of lines here, so we can make a better graph. This one is very static, we can't zoom in and out, and the labels are very close to each other, as I mentioned. So we can do a very better thing, that is using Pyb's library to make a more interesting visualization. So let's do it. Yeah, so now we have a much more interesting graph because it's more dynamic. We can zoom in and zoom out. Uh, we can visualize the strongness of each relationship. For example, the bigger the circle, the strongest is the relationship. So, for example, Harry and Hermione has a very strong relationship. Harry and Dudley also has a strong relationship. Harry and Dobby uh, also, and so on. One strange thing here is that Ronnie, one of the three main characters, is not appearing in this network, and I suspect that it's because Ronnie is Ronnie name is as a character is listed in the beginning of our project. Let's go back. So Ronald Ronald name is not in the book. We can see Ronald as Ron, but his name is listed as Ronald. So the algorithm didn't identify Ronnie as a strong character. Maybe we can back in some video in the future and fix this point. But by now, let's just move on and continue our analysis. So now let's explore the concept of degrees and centralities. They are based on the assumptions that the nodes that have many connections are the most important nodes. I mean, the most important characters. However, there are other centrality measures. For example, closeness centrality measures how long it will take to spread information from one node to all other nodes sequentially, and betweenness centrality measures how often a node acts as a bridge along the shortest path between the two other nodes. So let's see what are the most important characters according to these centrality measures. First, let's look to the degree centrality measure. Okay, let's plot it to see it. Okay, yeah, it makes sense. Harry is the main character. Hermione is one of the three main characters, and Ron doesn't appear here because of the point that I mentioned earlier. So let's look to betweenness centrality measure. Yeah, basically it gives the same result as the degree measure. And finally, let's look to the closeness centrality measure. And again, it basically gives the same results as uh, between is centrality measure and the degree centrality measure. Now we will save all the centrality measures into the nodes attributes in order to visualize the implementation of the last step of our project in this first video, which is community detection. Community detection is a very useful tool in graph analytics. In summary, if we have a social network, we can identify the communities that form the graph and from this get insights about how the network flows and, for example, how different communities interact each other. So we will create a dictionary with all the nodes and which community it belongs to. Then we set the communities as node attributes. So let's see the community. Okay, so Harry belongs to community 0, Vernon to community 1, Petunia to community 1, and so on. So now let's visualize the community's graph and see what happens. Okay, so it's very nice here. Each color is a different community. So in the blue community, we have, for example, Cornelius, Argus, Alicia, Severus, Minerva, Godric, and so on. That's all for today. Hope you liked the video. Don't forget to hit the like button because it helped me a lot. And also don't forget to subscribe to my channel to watch the next videos. Moreover, we are going to continue this project in the future. So in the next part of this project, we are going to analyze how the characters evolves over time. So basically, we are going to take the code we built today for just one book, and we are going to iterate it over all the books of the series to analyze how the characters evolves over time. So see you next time in the next video. Bye.